This is a problem using the fundamental theorem of calculus from the homework. This is a little bit weird looking, but it requires an algebra rewrite, obviously. But the algebra rewrite may be a rule that you haven't used in a while or you're not familiar with, and that is that when we raise a product to a power, so if we have the product of two numbers to a power, that's the same thing as just each one individually to that power. So the reason that's significant here is the product of those two, and that's not a complicated reason for that. If you did 2 times 3 to the 4th, right? That means 2 times 3 4 times, and so if you look at it, then if you multiply 2 times 3 times 2 times 3 times 2 times 3 times 2 times 3 across here, you've multiplied 4 2's. And you've multiplied 4 3's. So it's not a hard rule to see why that would be true. So can't even erase it. Well, all right. So anyway, so the idea here is that if we do a rewrite of this, right, the first thing we would want to do is make this a 1/2 power instead of a square root sign. But now we can use this rule that I just talked about. So I have 3 times x to the 1/2, which means that is 3 to the 1/2 times x to the 1/2. And again, I'm still just rewriting, but that 3 to the 1/2, that's just a number, right? That's the square root of 3. And so this is really the same problem. I can just leave that alone, leave the square root of 3 alone, and this is what I'm really doing is this problem. So the point here is that because this is multiplied, the 3 and the x are multiplied, you can separate the square root of 3x into the square root of 3 times the square root of x. And the square root of 3 is just a number, so it can be left out front, and then the square root of x is done like a normal problem. So, so if I were to go ahead and actually do this, I would leave the square root of 3 there. Antiderivative of x to the 1/2 is 2/3 x to the 3/2. I need to evaluate that from 0 to 3. Fortunately, when you plug 0 into this, it's 0, so you don't have to worry about the subtraction here. But I'll have the square root of 3 times 2/3 3 to the 3/2 as my answer, and that is can be simplified quite a bit actually. Because 3 to the 3/2, well, I could think of it this way, that this is really 3 to the 1/2. So if I multiply 3 to the 1/2 times 3 to the 3/2, then those exponents get added. So my 2/3 is still there. 3 to the 1/2 times 3 to the 3/2 is 3 to the 4/2, which is 3 squared. And so that's 2/3 of 9, which is 6. So this thing is pretty awful to look at, but because you have a square root of 3 here, that's a 1/2 power of 3, and then 3 to the 3/2, you can combine those, and actually there are no square roots of anything left in the answer.